Welcome to this particular lecture series, and in this particular lecture series, we will discuss the mathematical methods which is used to study the physical principles, and these are the mathematical tricks, techniques that we will use to study the physical principles in different branch of physics like classical mechanics, classical electrodynamics, thermodynamics, quantum mechanics, and similarly other branches of physics. So this is just a packet or a package where we will study the most of the mathematics that we need to study the master's level physics in India in the Indian universities, the syllabus that we have, right? So at the same time, this is the same concepts, the syllabus, which is asked in the entrance exams for PhD, right? Like CSIR NET or GATE, JEST, TIFR, and similar exams. So this is the mathematics that we have to know before going in detail in the physical principles. And this is the lecture that we will start discussing. And in this basic lecture, I will discuss the syllabus, the topics that we need to study, and this is just the syllabus which is mentioned in the syllabus of CSIR NET. So it is just that I will copy that whole syllabus in front of you just to give you an idea what is the mathematics which is required to study the graduate level or postgraduate level physics. Okay, so it is mentioned in the syllabus of CSIR NET that the first topic is dimensional analysis. So, and what is dimensional analysis? Dimensional analysis is just to look at the equation, right? And if you know about the physical quantities used in that particular physical mathematical equation, then what you can do, you just can use a little bit dimensional analysis, that the dimension of the right hand side must be equal to the left hand side in any of the physical equations, right? Or the mathematical equation which are used for the physical principles. The dimension of each term in this sum, if there are sums or different sum in some mathematical equation, so the physical dimensions of those terms has to be same, and just similar logic will give you some idea about whether the equation is right or not. So that kind of analysis we will do, dimensional analysis, right? The second topic that is very important if you want to study any of the branch of physics where you need to study the vector quantities, right? So like classical electrodynamics and classical mechanics, right? So if you want to understand those two branches, then you have to study the vector algebra. So the second topic that we will cover in this particular lecture series is vector algebra and vector calculus. So vector algebra and vector calculus. In this particular topic, we will study how do we add geometric vectors, how do we represent them in Cartesian coordinates, how do we take their components, and how do we do basic algebra, the scalar multiplication or multiplication by scalar, how do we take the dot product and cross product of 2, 3, and more vectors and so on. So these are very basic things that we will study in this particular topic. In the vector calculus, we will study about the operators like uh, divergence, curl, things like that, Laplacian. So those kind of operator we will study in vector calculus. This is the differential vector calculus. In the integral vector calculus, we will understand how do we integrate the vector fields. Right there, we will study about the line integral, the surface integral, the volume integral kind of thing. We will also study about the different coordinate systems like Cartesian coordinate system, cylindrical coordinate system, plane polar coordinate system, spherical coordinate system, things like that. And we will see how do we change the double integration into triple integration, single integration into triple integration, things like that, Green's theorem, Gauss theorem, etc. So all those things are just in this particular topic, which is the topic number 2, which is vector algebra and vector calculus. In the third topic is linear algebra. So we will study the linear algebra, which is the study of matrices, and we will see the Cauchy-Hamilton theorem. eigenvalue and eigenvectors. How do we calculate eigenvalues and eigenvector of matrices? So eigenvalues and eigenvector and things like that, right? We will see how do we diagonalize matrices. We will see different kind of matrices like unit matrix, identity matrix, null matrix, right? Upper triangular matrix, lower triangular matrix. So those kind of analysis we will do in this particular thing. We will also study about the vector spaces. We will study about the orthogonality kind of thing in this particular topic. Then we will study about the linear equations, linear differential equations, linear differential equations of first and second order. So first and second order. So again, this is very important, and you all have studied about how to solve the first order linear differential equation in your school mathematics, right? And we will emphasize more on the second order differential equation, which we will solve for the constant coefficient condition, and the second thing is about the variable coefficient conditions. So we will use those CFPI kind of things. So that is just very pretty straightforward way to calculate the solutions of second order differential equation if the coefficients of differentials are just constants. Study in detail the differential equations, the ordinary differential equation. The one thing is that these are ordinary differential equations. The fifth one is to study the special functions. So what are the special functions that we are interested in? So special functions like Hermite function or Hermite polynomial, right? Bessel polynomial, Lagore, Legendre, right? So things like that. So these are the four uh, second order differential equations: the Lagore differential equation, the Bessel differential equation, the Legendre differential equation, and things like that. And we will see how to calculate the solution for those uh, differential equations. And the solution which we will get will be these polynomials in X, and we will study these polynomials in itself in detail. We will see their orthogonality property, recurrence relation, and discuss these things in detail. So this is what is the just the differential equations, the vector analysis, linear algebra, uh, differential equations, linear ordinary differential equations, special functions. We will also study about the Fourier series, right? How to express any mathematical function in terms of sine and cosine series. So it is very important in physics, and we will see how do we do that. We will study about the transforms, Fourier and Laplace transform. So these are very pretty straightforward topics that you must have studied in your undergraduation or graduation already. So these are the topics. Now we will also study about the elements of complex analysis. Elements of complex analysis. Right, so it's the eighth one. Elements of complex analysis. In that we will study about the complex functions. In general, we are interested in about the analytic functions. So analytic functions. We are interested in the Taylor and Lorentz series. We are interested in the evaluation of integrals. So evaluation of integrals by using residue theorem, Cauchy residue theorem. We will study about the poles, about the singularity and different things. So it is just the outline, right? What we are interested in, but these are just the basic complex analysis, because the complex analysis is in itself a subject in mathematics. So if you will study the MSc in mathematics, then you will find that this is very detailed subject, right? And we are not interested in that detail, so we will just study the outlines of that particular subject, the basic elements of complex analysis. Then we will also study the elementary probability theory. Again, probability theory is very detailed subject, but just to understand the physical theories, we just have to know the elementary probability theory. So it is elementary probability theory. And in general, we are interested in random variables and distributions. So we will study about the random variables. And we are interested in Poisson distribution, binomial distribution, binomial distribution. We are interested in Poisson distribution, normal distribution, or one more thing is the central limit theorem. So these are just the basic topics. So these are just the basic topics that we are interested in, right, in this particular lecture series. And these are the topics mentioned in the part B, right? Part B paper of part B section of the CSIR NET exam. So these are the 9 topics that are mentioned, the basic topic as the basic topic. And for the advanced topic, CSIR NET mentioned these topics that I will mention there, and these topics will be asked just in the section C of CSIR NET. So it is the Green's function, the first topic, Green's function. And this is the topic which we will use in the study of scattering theory as well. Even it is very useful. It is useful in the study of electrostatic problems to solve the electrostatic problem, the solution of Laplace equation and so on. And this is very important function in physics, so we will study about this. We will study about the partial differential equations. And in general, we are interested in Laplace equation. We are interested in the wave equation. You all have studied about that particular equation already in your undergraduate, but we will study this equation in much more detail in second dimension and third dimension, right? We are interested in heat equations, right? Heat equation in 2 dimension and 3 dimension. Then we will move to the computational physics, the elements of computational techniques. So elements, again, computational physics is very vast subject and you have to devote a lot of time, but just to qualify this particular exam, you don't have to go in that much detail. You just have to know some basic elements. So elements of computational techniques. And in that we will understand how to calculate the roots of linear and transcendental equations. So linear and transcendental equations. We will also see how to integrate the functions. So integration of function, right, by using trapezoidal method and Simpson method. We will understand how to solve the first order differential equations. So first order differential equation, right? So these kind of things we will understand how do we do by using computational techniques, right? Then we are interested in tensors. These are the mathematical objects that we use to study the physical properties in general. If you must heard about them, that this is the basic mathematical quantity or entity or mathematical object. You must have to understand if you want to understand the general theory of relativity, because this is the object that has been used there to express the physical quantities. So it is very important mathematical constructs, and we will understand how do we define the tensors, and then how do we do algebra and calculus on those tensors and the tensor quantities. And the last one is just the introductory group theory. And especially we are interested in special unitary groups of dimension 2 by 2 and orthogonal dimension 3. So these are the basic topics that we are going to cover in this particular lecture series. and we will discuss almost everything in detail. And this is the syllabus of CSIR NET. You just have to go to the website and just check. It may be, I think I have mentioned all the topics, but it may be that if I haven't mentioned any one of the topic or two of the topic, then you can check those things from the CSIR NET syllabus. But this is what we are going to do in this particular lecture series, and we will solve a lot of already asked problems in CSIR NET, GATE, JEST, TIFR, etc. Right? These exams are the compulsory exams if you want to do physics in India, right? So if you just want to continue doing physics, then you have to write in your career at some point. You have to write one of these exams to get the admission in some of the reputed institute in India, right, to do your doctorate training. So you must have to prepare yourself according to these exams so that you can qualify these exams uh, just a little easily. So this is it in this particular lecture, and in the coming lectures we will discuss these things in detail. So thank you for this particular lecture.